So if you remember, we talked always, last 4 lecture, we just talked about this function which defines for you the number of the accessible states. So on the last lecture, I tried to explain you that this omega e is proportional to the volume or area of the one space with 3n coordinates. We call it nr, or from 1 to 3n, so you can use x also. And everything was related to find the volume of this hypersurface 8mv2eh square, we call it this r square, was related to find the volume of that. But there are a lot of questions about why this is actually defined a discontinuous set of the coordinates. So if you just consider the case when you have just two quantum number n1 and n2, so the counting problem is related to the counting the number of the point. Yes, and we don't know how many of these points are enclosed in this surface. So you needed to know that how many of the points are located inside this circle. If you consider 2 dimensions, because I want to have a just idea about what to do. So this is about when you have a 2 quantum number. So this is a very non-realistic model, because with 2 numbers, it means that you have one particle and this one particle moving in 2 dimensions. So nx and ny are a set of the quantum number, and they define a model for the moving for a free particle in quantum mechanics in 2 dimensions. But normally we have a 3 dimension. So just I give this picture because you have just 2 ideas. So it's very difficult to know that how many of the points are located. There is another case is that these 2 points are completely separated from each other. If you have a set of the number here, but there is another set here, and there is no any correlation, there is no any relation between these 2. I mean, they are a set of the integer number. They should be the set of the integer number. So all the nr should be some integer number. I mean 0, plus, minus 1, plus, minus 2. But minus we don't consider the minus numbers. Plus and 1, 2, 3, anyway. But we are going now to find the area or surface from that. So the first question which I expected you ask me, but you didn't ask me, is that when you have a set of the discrete point in the space in 2 dimensions and later to 3 dimensions, how you can define the surface or area, and what's the relation between the area and the surface and the set of the discontinuous point in the space. This is exactly like the difference between this, you call it this in sequence in the calculus, and the function.
Yes.
They are completely different. For one of them, actually, this n run from the 0, 1, 2, 3, and there is no any, for example, a half or a 3 half or 4 half. So this is the sequence of the discrete. This is our case. Actually, this is the case of quantum mechanics, when you have a discrete number of this thing. And this is the case of the normal case. Sometimes you can have a pyramid and allow the pyramid to be freely moving, freely changing from the minus infinity to plus infinity. That's possible. But not always. But this is the case of the statistical. But you can relax and set this a n like a function of the n. I mean, you can consider that this discontinuous set as a large number of the points, and finally you can be sure that it made for you a continuous surface, because you have a lot of number. Why you have a lot of number? Because our quantum mechanical system is highly degenerated. What does it mean? It means that the number of the existed states with the definite energy is very, very huge number. So it's in the order of the n, actually, in the order of the Avogadro number. So for the very large number, because n is very big, as I told you, and normally n tends to infinity from the mathematical point of view, so that you should not be worried about that the surface is discontinuous surface, so it can make for you continuous surface. This is a one point. The second point was that I explained to you that between the area and the surface there is no difference. Yeah, that's true. You know, if you're looking at the 3 dimension, just consider a simple three dimension configuration of space for one particle. So volume of this surface, I can call it V3 because you have a one particle and you have a 3 dimension actually. This can refer to the number of the particle. And this is the R is that. I want to tell you that the volume for that, the volume is proportional to the R cubic, huh? It's proportional to the R cubic. I know that it will be 8 pi or something, generally. And the area of that, area of what area? Area of the surface of that. So area of the surface will be proportional to R squared. So actually there is a difference, there is a relation between the volume and the area. So the volume can be written in terms of the some proportionality R multiplied to ds, or volume can be written as the, that's true? Yes?
Yes.
Volume differential will be R squared and differential of the S will be R, so R multiplied to R, that will be balanced always. But what is here, so what is the here? So if you consider that for the higher dimension, like n dimension, I expected that dvn will be Rn minus 1, yes, S, ds n minus 1. Yes.
So R minus 1.
You can have also the constant here. N minus 2, you can write it as. Okay. N minus 2. Okay. So, and the volume is Rn, and the Vn is actually some constant multiplied to Rn. This is the case of the volume. So in your case, you have the R here, so this is the R. So I want to find the volume for the n-dimensional hypersurface. So the strategy is really some very rare idea actually. Vnr is the volume of this n-dimensional hypersurface, or n-ball is given as the n triple or n plus function integration over the coordinate, I call it dxi, I from 1 to n. You know that what happened here is that instead of the discrete quantum number ni, I use the continuous variable xi, but it's okay because I told you the system is highly degenerated actually. So the integration is limited to the I need to find that. This is the case of the integral. So it's very, and we remember that what is the d pi of the dxi? So p pi of the dxi and I from 1 to n is just the volume of this n, dvn. This is the exact thing. And remember that the Vn is Cn Rn, some constant multiplied to Rn. So if you make a direct differential from that, so n Cn Rn minus 1 dr. From the other point of the view, that should be equal to the differential form of the area multiplied to R. So it will be SNR dr, something like that. This is the SNR, just so I make it this title for. So the question is how to make this integral. So if you have a two coordinate, if you have a two-point number, so you know how to make the integration. Of course, it's very easy to do the calculation if you have it just two ways. I mean, if you wanted to do that, dx1, dx2, and you are restricted to x1 to x squared. So this is actually the area of the disk. Area of disk, not volume. This is the area of disk, and you need to do that like that. dx1, I just write it minus 1 r squared minus x1 squared, elementary calculus task. So after the integration, you will find r squared. If you have a 3-dimension, you can repeat that. For n-dimension, you need to use another strategy. Otherwise, if you want to use the same strategy for n-dimension, you will have a huge number of the radical, and you cannot survive, actually. So I use a very unconventional way. So you know that the only problem is this Cn. If I can get the Cn, everything's will be easy. Just we needed to find the Cn. We use a very unconventionally, we use the integral, we call it the Poisson integral. Poisson integral is one of the integrals which improper integral, and that's the form of the integral is like that. Do you remember how to find this integral? What is the strategy to demonstrate that?
First, we need to convert x squared. We need to square it, and then we have x squared plus y squared. Then we change it to r squared. We will change it to
not change to r squared.
X squared plus y squared.
You pass to the polar coordinate. Yes. You pass to the polar coordinate. Yes, that's the. Yes, this is the domain of integration. So domain of integration is the whole two-dimensional space. So instead of that, you can define the coordinate r as you told me, theta, and you can make it just this integral multiply and pass to the polar coordinate and define it. I don't do this calculation here. But this is the elementary method. This is from the calculus one. The other method is that you need to know that what's the gamma function, the factorial function, because we needed that. We need to know that the generalization of the factorial to the any number. So that's I will also introduce you later. So okay, if I write this integral n times, so it means that I can repeat the integral n times here. E minus x1 squared, x2 squared plus xn squared. dxi pi from I to n. That's and it will be Pn over 2. And this is the dvn. Okay, now I can pass to the something like call it n-dimensional spherical coordinate. N-dimensional spherical coordinate. I wanted to do a trick, and the trick is that I can write that this Cn Rn minus 1 dr. Everything about the angles is stored here, is saved here, the information about theta phi. You remember in 3 dimension you need theta phi, for 2 dimension you have a 1 theta. Everything is here. the azimuthal part of the integral is saved here actually. And now very quickly we can define that. Can I use another? Okay, I can use this thing, no problem. So I can write that 0 to infinity, e minus r squared, cn, rn minus 1, rn minus 1, dr. So this will be pn over 2. Now the challenge is that to find this integral. If you find this integral, the cn. So this is a very tricky. So you need to repeat this, and you need to think that how to convert this n-dimensional integral to one-dimensional integral. So, and you see that the domain is changed because this domain is something of a Cartesian coordinates. And here we use it some kind of the polar, not spherical, hyperspherical coordinate. Spherical coordinate, we use it then. And that's all. So you need just to know this. If you know that, you can find it here. So I need to find this integral for you. So I will do that. And after that, you will get the volume. In mathematical physics, there is a function called gamma z, 0 to infinity, t z minus 1, e minus t dt. This function z minus 1 factorial. This is a formal representation of this function. So this is the definition of the factorial. You can write for any number, for example, factorial of 1 over square, 1 over 2, or something. 1 over gamma is z, gamma minus n, and n if n is started from the integer, so this is 0 by the definition. And for my business, I want to know that what's this integral. So here, if you change the t to r squared, so dt will be 2r dr. So you can make this integral change to, and the domain doesn't change, so I mean passing from the r to the t was from 0 to infinity, so that's from the 0 to infinity, the same. What is the t? See, r2z minus 2 multiply e minus r squared 2r dr. So it will be 2 integral 0 to infinity r 2z minus 1 e minus r squared dr. And this is, what's that? This is z minus 1 factorial. This integral, I know that this is just I changed the coordinate, so just I use the change of the coordinate in the both sides of the integral, so I get that. And compare that with your case, you see that you find this information, r2z minus 1, e minus r squared dr is 1 over 2 z minus 1 factorial of 1 over 2 gamma z. In your case, r squared you have n minus 1 instead of the 2z. So you just replace it 2z by, yes, 2z should be replaced by the n, so it means z replaced by n squared. Finally, I want to use this information, Cn 1 over 2 gamma n over 2 will be Pn over 2. So this is one of the very important equations we will use. So Vn, the volume of the n ball, is given by the 2Pn over 2 gamma n over 2 Rn. So this is the equation. As an easy example, just put at the n1 and you can demonstrate that V will be volume will be the length. For the 2, if you have a 2-dimension, so you have a V2R, you can show that that will be reduced to PR squared, and for n cubic 3, so the volume will be reduced to the famous formula of the volume, and for higher dimension you can use this equation always. In your case, in the statistical mechanics, we have not n, we have a 3n. We have a 3n. So instead of the n, I need to use 3n. So I can write for you now the omega. Now we can write omega. So omega E is the volume of 3n ball with radius. What is the radius? Radical 8m v 2 power 3 e over h squared. Just replace it this here. And